By the end of this module, you should be able to identify key heat pump components and summarize how heat pump components work.
A heat pump is a complex system consisting of several key components working together to transfer heat between indoor and outdoor environments. Let's explore these components. Evaporator, condenser, compressor, expansion valve, piping and tubing, sensors and control systems, and oil separator and accumulator. The key components of an evaporator in a heat pump system include expansion valve, evaporator coil, and fins. The evaporator coil is a vital component of the indoor unit in a heat pump system. It consists of a network of tubing, usually made of copper or aluminum. This coil is responsible for absorbing heat from the surrounding environment, which can be indoor air during the heating mode or from an external heat source, like outdoor air, ground, or water, during the cooling mode. Fins are thin, metallic sheets or blades attached to the evaporator coil. They serve the purpose of increasing the surface area of the coil. This increased surface area enhances the efficiency of heat exchange between the refrigerant inside the coil and the surrounding air. The expansion valve is a critical component located near the evaporator coil. It plays a pivotal role in the refrigeration cycle. This valve reduces the pressure and temperature of the high-pressure liquid refrigerant coming from the condenser. Heating mode. In heating mode, the evaporator's primary function is to absorb heat from the indoor air. As indoor air is drawn over the cold evaporator coil, the refrigerant inside the coil evaporates. This phase change from liquid to vapor requires energy, which is obtained by absorbing heat from the surrounding air. As a result, the indoor air is cooled down while the refrigerant in the coil becomes a low-pressure, low-temperature gas. This warm refrigerant is then sent to the compressor to initiate the next stage of the refrigeration cycle. Cooling mode. In cooling mode, the evaporator's role is reversed. Instead of absorbing heat from indoor air, it now absorbs heat from the heat source, which is typically outdoor air. As the refrigerant in the evaporator coil evaporates, it extracts heat from the outdoor air. This cooling effect causes the refrigerant to change from a low-pressure liquid-gas mixture to a low-pressure vapor. The chilled refrigerant is then routed to the compressor to continue the refrigeration cycle. The evaporator is typically housed within the indoor unit of the heat pump system. It is strategically positioned within the air handler or furnace. The placement of the evaporator coil within the ductwork or air handling unit ensures efficient heat exchange with the indoor air. The key components of a condenser in a heat pump system include refrigerant coils, fan, compressor, condenser coil fins, and refrigerant lines. Fan. The condenser features a fan that enhances the dissipation of heat from the coils into the outdoor air. Refrigerant coils. These coils, often made of copper or aluminum, carry the refrigerant and facilitate heat exchange. Compressor. Responsible for pressurizing the refrigerant, raising its temperature, and preparing it for the condenser. Condenser coil fins. Fins attached to the coils increase the surface area, optimizing heat transfer. Refrigerant lines. These lines connect the condenser to other system components, allowing refrigerant flow. Refrigerant leaks. Leaks in coils or refrigerant lines can result in reduced system efficiency and performance. Fan problems. A malfunctioning fan can hinder heat dissipation, potentially causing the condenser to overheat. Dirt and debris. Accumulation of dirt and debris on the condenser coils can reduce heat transfer efficiency. Coil corrosion. Over time, the condenser coils may corrode, impacting heat exchange and potentially leading to leaks. The key components of a compressor in a heat pump system include cylinder, piston, motor, and valves. Cylinder. The compressor typically contains one or more cylinders in which the compression of refrigerant occurs. Piston. Within each cylinder, a piston is responsible for compressing the refrigerant vapor. Motor. The compressor is equipped with an electric motor that drives the pistons to create the necessary pressure and temperature conditions for the refrigerant. Valves. Compressors have inlet and outlet valves that control the flow of refrigerant in and out of the cylinders. Several issues can lead to the failure or malfunctioning of a compressor. Electrical problems. Issues with the motor or electrical connections can disrupt the compressor's operation. Refrigerant leaks. Refrigerant leaks in the compressor can reduce its efficiency and overall system performance. Compressor overheating. Overheating due to poor ventilation, dirt, or debris can lead to compressor failure. Oil problems. Lack of proper lubrication or oil contamination can damage the compressor. Mechanical wear. Over time, wear and tear on pistons, valves, and other components can affect compressor performance. The key components of an expansion valve in a heat pump system include valve body, orifice or restriction, and adjustment mechanism. Valve body. The main component of the expansion valve is the valve body, which houses the various internal components and controls the flow of refrigerant. Orifice or restriction. The expansion valve contains an orifice or restriction, often a small opening or a fine passageway, through which the high-pressure liquid refrigerant passes. This restriction causes a sudden drop in pressure. Adjustment mechanism. In some systems, especially larger or more complex ones, there may be an adjustment mechanism to control the opening of the valve, allowing for fine-tuning of the refrigerant flow. Common failure modes of an expansion valve can include blockage. The orifice or restriction in the valve may become blocked or clogged over time, reducing or completely obstructing the flow of refrigerant. Stuck valve. The valve may become stuck in an open or closed position, preventing it from regulating the refrigerant flow effectively. Improper sizing. An improperly sized or adjusted expansion valve can lead to inefficient cooling or heating performance in the heat pump system. Mechanical damage. Physical damage to the valve body or its components can result in refrigerant leaks or improper operation. In conclusion, a heat pump has different components, each with a specific role.